I'm recording the class. And I made Miss Gomez co-host before she had to tell me. I mean, it was only for 2 classes out of the 3, but hey, I'm getting there. I'm getting there.
No, the first one you did.
Well, that's why I said 2 out of the 3, because I didn't do that for a second period.
Oh, yes, okay.
So today's going to look very similar to what we did yesterday. I want to go through this very quickly because the last couple of classes we've been going to the bell. Actually, last period it was a little bit over, and since next period is lunch, I don't want to do that. So we are going to be doing day 2 of shading grids.
It's okay.
Huh?
It's okay. It's okay when lunch. It don't matter. It's just lunch.
I want to eat, and then I have to go to tutoring. So it might be fine for you guys. It's not fine for both of us because, you know, we need to eat.
Yeah. We're not done at 11:30.
Eat during class.
Eat during class.
Oh, eat during class.
All right. So we're going to do day 2 of shading grids. After that, Ms. Gomez is going to take over again. She's going to do pages 6 and 7 in your notebook. Remember to log in versus typing in some random names. We're still getting problems with that. It's still the exact same week 3 that we did on Tuesday at the very bottom of week 3. So, you know, don't forget that part. And then if you guys are coming for tutoring, remember it's from 12:10 to 1:10, Monday, Tuesday, Thursday, Friday, 12:30 to 2 on Wednesdays. We are going to have a quiz next week. We're going to let you guys know, you know, roughly what to work on. But it's not till next Friday. It was supposed to be today. And then I was like, no, we need to move it on to next Friday because next Friday it'll just be the quiz with, I think, 1 assignment.
I'm kidding.
And then again, if you guys are coming to tutoring, click on the computer and that'll send you to tutoring. If you want the other tutoring later on in the day, click on the, I need to move this guy over to the Apple or the Apple phone, and it'll give you guys the link for the other one. But all of you guys right now should be under week 3 and click on Desmos. Oh, exit ticket. Please make sure you guys are doing the exit ticket. Even if we go until the bell, yes, or the quote unquote bell, yes, you still need to do the exit ticket. I know it's going to be late. It's fine. Do not leave or don't go to do something else until you hit that exit ticket. If you forget, send me a message because once I give you guys a 0, I never look at those again. All right. So if you guys forget and I already gave you guys a 0, send me a message saying, sorry, I totally forgot, but I was here. I'll look at my notes to see if you actually participated today, and then I'll give you guys your points, but try and remember to actually come in for class. All right. And don't forget to turn in your stuff. No. So some of you guys, it says that like some of you guys submit it multiple times, even after I give you guys your 3 points. So sometimes look at the corner and see if you guys got your points, because it might not have turned gray, but just look to see if you guys got points, because yes, like you turned it in. I gave you your points, but then you returned it in because it must have like glitched and said that you didn't turn it in, but you did, and I had seen it. But it's better to be safe than sorry and turn it in twice versus not turn it in at all. So good on you. So again, we're going to be on shading grids day 2. Don't click on day 1, it's day 2. Make sure you log in with your district email and password. Make sure you have your full name. And it should be a green and purple blocks this time. And I, again, can see absolutely everything that you guys are doing.
Oh my God,
Big brother.
Everything.
I see everything. All right. So as you guys are logging in, because I still see a lot of you guys logging in, totally fine. I'm gonna at least get started. Again, we do have a crunch on time. So just like you guys did yesterday you had red blocks and you had blue blocks. Now you have green and you have purple, but you're following along the exact same way as you did yesterday. You're going to count the blocks. Now, this is a lot of blocks. You might not want to count all of that. So you can count going side and down because that's the length and the width, and it'll tell you what the area is. Ooh, review. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8 by 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 gives me a 64. That looks nothing like a 4.
Yeah.
Also, I'm getting messages. If you're having any issues, let me know. All right. So that
what was,
huh?
What was the first number?
64.
64.
Yes, that's why we're counting the side. How many you go across and down? So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4, 32. 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4, 16. And you're gonna keep going. This time, because of the amount of blocks we have, or at least not necessarily for the green, but definitely for the purple, you don't have to color it in. All right. Unless you really want to. And then for purple, you're gonna do the exact same thing. And I said 3 instead of thing. And finish off the last 2. Man, some of you guys are fast.
Oh, wow. Yeah. As
Like,
you said that, I started seeing answers.
Yeah. Like, now, if you can't figure out the green, you might be able to figure out the purple. So you don't have to go in that order of green and purple. You can do purple and then green. But a lot of you guys are already done with the green one, which is amazing.
That is fantastic.
Oh, I think I get pattern D.
Let
put
me
it in chat.
look at yours.
Hold on. Yep. Hold on. Let me put it in chat. I think it is. Where are you? Host.
But everyone that has tried the green, you guys are 100% right. And those of you guys who are trying purple, you guys are right.
Yeah. Job, you guys.
So
Hiram, yeah. Yeah, you are.
Okay.
So good job, guys. I'm gonna give you guys another minute. Again, you don't have to color in those boxes. But that's gonna take you quite a while.
Let me get this one. 64, 32. 64, 32, 16.
So think, what can I do to 64 to get 32? What can I do to 32 to get 16? And it should be the same thing each and every time.
Divide by 2.
Have I asked for answers? Junior? Really? Wow.
Thank
you.
Thank you.
I mean, granted, now you gave everyone the answers. All right, so that'll be a segue to, getting into this. So yeah, we are dividing everything by 2, or at least for the green. We're talking about the green. So we're dividing this by 2. dividing this by 2. All right, so 16 divided by 2 gives me what, guys?
8.
Thank you. So this is going to be an 8. 8 divided by 2 would be what?
4.
4. So that's this one. So if I wanted to follow the pattern, it would look like this. Some of you guys have it going long ways, but look at the patterns here.
Mhm.
Like this was an 8 by 8, right? Then, 8 by 4, then 4 by 4. So then this should be 4 by 2. So I'm cutting this
Mhm.
in half, and then this in half, and then this in half. So then it should be as 4. What did I do? What's the rule for the purple? How do I go from 3 to 9, 9 to 27?
Multiply by
You
3.
multiply by
You guys are fighting over who's going to answer. Multiply by 3. Perfect. So if I multiply 27 times 3, what do I get?
81.
81. And if I multiply 81 times 3?
43.
2, 4,
43. I thought I heard
3.
43.
No, 2, 4, 3. She just like clicked and the 2 didn't come out
Yeah.
when she's talking. All right. So, and obviously I'm not going to ask you guys to like draw yourself because no. All the other classes have been having a little bit too much fun with drawing. So we can move on. Look at slide 2. It's asking you guys, how are patterns C and D, which is these two, the same or different than the ones that we did yesterday?
They're different colors, Doc.
Good.
That's one way, yeah. So again, are we asking for rocket science
answers?
like answers? No, but we do want anything. These are your thoughts. So what we're looking for is an exploration, guys. So we're exploring the ideas of linear versus exponential right now. So we're seeing all the different patterns.
And the number is 3 instead of 2, and we're dividing and multiplying.
Yeah, so all of that stuff, type it. Here, the next one is going to say, do you predict that pattern C and D will be linear, exponential, or something different? Yes, and I'm going to go back so that you guys can see the patterns, and that way you're not having to go back and forth. So I'll leave this part here, but I would like you guys to answer slides 2. So all of you guys should be on slide 2.
Doc.
Monday.
Pattern A and B were the ones from yesterday, right?
The pattern A and B are the ones from yesterday, yeah. The red one and the blue one. So the red one, A, was going up by 2, so adding 2, and pattern B, which was the blue one, was multiplied by 2.
Oh, okay.
And if I could draw on the side here, I would write that out, but I can't. So a lot of you guys are talking about
Ooh.
the numbers. Some of you guys are talking about, that you're expecting them to, a lot of you guys are saying that they are going to be exponential. Some of you guys think maybe it's linear for the ones that's different. Where's my troublemaker at?
Right here.
Hi, Ren. Not you, for once.
I see some good answers here.
Doc.
Monday.
So since it's division, would it be divinitional or something? I'm just making up words. I don't know.
I love that. What's got you thinking that it's something else, maybe?
Doc, I'm excited for today.
You're excited for today.
Yeah, because we're going to do ribs.
Ribs?
I thought you were talking about math. That's why she was happy, but you're like ribs.
Oh.
You gonna invite me?
I don't know. Yeah,
When
by
you
the time
say-
you gone.
Ribs sound good.
Yeah, I was going to do the
Ribs.
ribs and short ribs.
See, I'm hungry now. Thank you. Thank you,
I
Junior.
am too. You're gonna buy me food.
Hey, shh, focus. All right, so we're gonna move on. So a lot of you guys were having a couple of things. A lot of you guys are still kind of a little confused because you're kind of sticking to the, well, they have different colors. So totally fine. This is again exploration. We are just starting. We just started this yesterday. We're moving on with this today. We're gonna go into everything this week or next week. So it's totally fine. All right. So happy birthday. It was my son's birthday yesterday. And then again, some of you guys are thinking, yes, this is going to be exponential. Some of you guys are like, I don't know. Maybe it's linear. Maybe it's both. Maybe it's something. So let's see. So just like we did yesterday, I want you guys to go to, and I'll have slide 1 open so that you guys can type it in. But you're going to go back and forth and you're going to fill in the table. So I'm going to fill in the green one. You guys can fill in the purple one. You do not need to go past, what did we go? 4, 5, 5. Don't go past 5, especially not with, the second one. Those are big numbers. All right. So first one, we had 64, 32, 16, 8, 4. Sorry, for a second I was like, did I do that right?
You got them.
So we're noticing what
that?
kind. So it's 64, 32, 16, 8, and 4.
It's
And then
exponential
it's
Ooh.
exponential. How do we know that it's exponential?
because it's a curve.
Yeah.
But
It's a
since it's
curve.
going down, is it negative?
Ooh. And that's where we're going to head towards by the end of this period.
Mm-hmm.
So start thinking,
Good job, you
what makes it like that? Now, if you guys want to give it a go, you could try and write the equation. And I will let you know, it's probably easiest if you click on the keyboard one. We normally don't use this, but especially since we have exponents, I'm going to give you one that's super not right. And I'm going to write 7. I'm going to click on the A to the B button. And that makes it into an exponent. So if I wanted to put a number, I could. If I wanted to put X, ooh, all of a sudden I see that curve, but it's not the right curve. All right. So you could do that. Do you have to write the expression? No, you don't. It is just if you guys want to give it a go, but first fill out the tables. Don't go past 5. Now, if you look, especially for the bottom one, the purple one, you might have to zoom out a little bit. Don't zoom out too much because then you're not going to be able to see that curve. You want to just be zoomed out just enough so that you can still see that curve, but see all of your purple dots. And if you go too far, you can click on the little house and it'll send you back to where you should be. So I'm going to turn this off because if I don't, then I'm going to be like, wow, one of you guys is actually trying. And then it's like, oh, no, wait, that was me.
Doc,
Monday.
I did my nails yesterday.
Hiram, pay attention to the lesson. These
yeah.
conversations can be done during tutoring.
Okay.
So again, you guys should be doing both tables. I see a lot of you guys already like have the green one down. You're starting on that purple one. Great. I am, because I see a lot of you guys are already switching, like getting that. Ooh, some of you guys are trying the equation. That's super nice. I like it. Oh. All my blocks are going all over the place. Ooh, so close. I like it. Ooh. For a second, one of you guys actually had it like turned the correct way.
Doc, I did it.
Did you? Wait, I don't see it. Wait. Well, you did the purple one, yeah. Good.
Oh
So
yeah.
you might not be able to do the green one yet, because that one's gonna be not a little, but a lot different. But that purple one, you should be able to get the purple one, at least from what we started yesterday. But if you at least have done both of your blocks, so the purple block should look like 3, 9, 27, 81, 2, 4, 3. And see, it's all the way that way. So we do see a pattern going up. It is also a curve. Whoa. So we are still seeing that. So it's a curve, but one's kind of curving up and the other one's kind of curving down.
Mhm.
So
Ooh, what is that?
I would switch over to slide 4. Some of you guys are bound and determined. No, I'm going to get this. So we're going to switch over. See, someone
know
is
what-
so close.
Yeah, I
And then
just
they
saw
keep
that.
turning it off. It's like
Hmm.
it's close for a second and then it disappears. All right. So switch over
Doc.
to slide 4. Yeah.
How do we make the line move to the right?
You're way ahead of the game.
You will find out, but not today. Maybe today.
Oh, but I would say that what you're trying to do at the end there, that's how you're shifting it. So you're just
You're
a
getting
little
there.
ahead of this. Yeah.
So I would like you guys to switch over to slide 4. Just like yesterday, we're going to look at the pattern that we're building in our table. And we're going to write, what did we do going from one to the other? Now, what was our pattern for the purple? Can anyone let me know?
Multiply by 3.
I was multiplying by 3.
We're multiplying by 3 for the purple.
Multiply by 3.
What did we do for the green?
We divided by 3.
Not by 3, by 2.
By 2, I mean.
So, I'm going to give you a hint for this. Remember yesterday, Ms. Gomez was telling you guys, if we're doing linear, we're adding, right? We should have an adding pattern. If we have exponential, which looking at our graph, we know both of these are exponential, then we should have a multiplication pattern. And if these patterns are, I'm multiplying by 3, should I write this as divide by 2? Or is there a way that I can write it as a multiplication problem? Does anyone know? Say that one more time, Junior.
You can
Lisandro.
go reverse.
What do you mean by reverse?
Reverse.
Oh,
You guys are all lagging at this
Thanks.
point.
Are they?
For me, they are.
And instead of going down, it could go up and multiply.
Oh,
Do you hear him? I don't hear it. Like,
I understood that he said
I don't
if
hear
you
him.
start from the bottom, you're multiplying by 2. That's what he said.
yes,
Yeah.
that's true. But we can't write here, we can't write the number multiplied by 2 because that's not the operation that we're doing. So what I'm trying to get at is instead of saying divide by 2, another way to write a division is to write multiply, but use a fraction and say multiply by 1/2. So whatever the number is, so if I'm dividing by like 5, then I would multiply by 1/5. So whatever that whole number is right here, I'm going to put it on the bottom of our fraction. Does that make sense? So instead of us writing divide by 2 each time, we can say that we're multiplying by 1/2, because remember, for exponentials, our rules should be to multiply by a number. So once you're done filling this out, look at your 2 questions. It says explain clearly whether these functions are linear, exponentials, or something else, which we've already covered. You guys already told me that on this slide. And then explain in a clear sentence how an exponential function grows. So look at the difference between this number right here and then this number right here. And I'll erase this guy right here. So how can you tell that something is going to be growing based off of the numbers in our pattern? These guys right here. I love how all of you guys have started your sentence. Exponential functions grow, and you're waiting there for me to like give you the answer. Again, look at this number. I'm multiplying by 3 and my number is getting bigger. However, when I multiply by 1/2, my number is getting smaller. Compare 3 to 1/2. That should help you. Does that help? Let's see. I'll start reading your answers. Excuse me. So again, and I'll help you guys a little bit more. Think about this. 3 is a whole number. If we're looking at a whole number and we're multiplying, obviously my numbers are going to be getting bigger and bigger and bigger. However, if I'm multiplying by a fraction, that means we're dividing. So if we're multiplying by a fraction, then obviously our numbers are going to get smaller and smaller and smaller. All right, keep that in mind. I'm going to open up the next slide. Actually, I'm going to open up the next 2 slides, because there's only a couple of questions left. So on question 5, or on slide 5, it says grid patterns B, which was the one from yesterday, and both the ones for today, C and D, are exponential growths. B from yesterday and D for today, which is purple, are both exponential growth, while C, the green one, is exponential decay. Explain how the multiplier being what we're multiplying to both of them, determines if the function will grow or decay, which is basically what I had just said a moment ago. So tell me how looking at the 3 and looking at the 1/2 can let me know if it's going to be a grow or a decay. Decay means I'm getting smaller. It's I can't stop yawning. I need a nap. No, not a nap. I think I just need food.
Yeah, probably.
No, he already gave me a cup of coffee. Thank you. So again, we're talking about, look at the 3 compared to the 1/2. When I have a whole number 3, my numbers are growing. When I have a fraction, that means I'm dividing by that number on the bottom. So then obviously I'm going to have a decay. So that's for 5. And for 6, once you guys get there, summarize, let me know just something that you guys learned. And if you guys still have any questions on something, maybe you do, maybe you don't, write this up. Once you guys are done, go to Google Classroom and mark it as done. Some of you guys are forgetting to do that. All right, same thing goes with ClassKick. I don't grade it, like, I'm not notified in ClassKick once you're done with your assignment. It's in Google Classroom. Make sure you go to Google Classroom first and mark it as done. So once Ms. Gomez is done with the notes for today, come back here and then mark your notebook as done for today. But you guys will have 2 questions for homework. And if you guys haven't done yesterday's 2 your turn questions, then you still can't click on this. It has to be 100% done before you guys click on this. The your turns do count. If I don't see the your turns, I am going to dock you guys a bunch of points. So at this point, you guys should be on slide 6 because I've given you guys this answer a few times. You guys should be on slide 6, letting me know what did you guys learn today? And then if you guys have any questions left.
Doc, I don't want to leave the number 3 until I figure out the equation, but I have to.
Well, you can, we'll let you know during tutoring.
I almost have it. I just need to turn it the other side.
Let me see, where's Jessica?
Well, here, let me give you guys a hint. Pay attention to these numbers. These numbers need to be in your equation in some form or another. All right, I'm going to stop sharing to give Ms. Gomez the floor.
Oh, yes.
You guys should be finishing up that assignment, going into Google Classroom, marking it as done. Do not forget to do that.
Don't forget, go to Google Classroom. Should be sharing that right now. Okay. Desmo's shading grids day 2. Okay, don't forget, click on that. For those of you finishing up, we're going to be going into the Classkick notebook. So that is the last option here on week 3. Week 3, linear versus exponential functions notebook. Okay, you want to click on Classkick. For your notes, make sure you're logging in so we keep track of your notes, and we can see when you're finished and when you've completed the whole thing. So since today's Friday, you should be finishing up your notes on Classkick here for your notebook. So you guys log in. I'll be entering Ms. Gomez 3. Today, we're going to be working on pages 6 and 7. So I'll give you guys some time to get there. Give me a thumbs up if you're there, or give me a clap if you need some more time. Okay, I'll give you some more time. I know some of you might be having internet issues, so if you're not able to access your Classkick notes, you should be following along with us on Zoom, and we can let you take some screenshots at the end and you can finish that up after we're done with Zoom. But we can see who's following along with us. And Doc Brown has that screen on her side, okay?
I can or can't?
We can.
Oh.
So we can see who's opened it, who's on the same page as us. A thumbs up if we're good to go. Okay. Okay, so today we're going to be talking about linear versus exponential functions. We're still going to be comparing them. So some of you might be looking at that page 6 on Classkick and you might be saying, wait a minute, this looks exactly like yesterday. It does a little, but the tables are different. And there's a reason why we still have them side by side, because we still want you guys to see how they're behaving differently. The only thing is that you did not see any linear functions today. They were both exponential, okay? But we really wanted you to focus on how the exponential functions differ when we're increasing and when we're decreasing, how they have a different pattern. So we are going to be reviewing your linear functions, the decreasing ones, but you've seen those. And then we'll keep talking about your exponential functions. Okay, so today's objective is that you should be able to identify a decreasing linear and a decreasing exponential function from a table. And you should also be able to identify some features. the pattern, which is our rate, and the y-intercept. There's a reason why we keep stressing so much on the pattern and on the y-intercept, and that's because some of you that were really trying to get that equation, it comes from these two steps that we're giving you guys today. Okay, so just a little review. For your linear equation, there was two things you needed. The y equals mx plus b. You needed the slope. And you also need the y-intercept. These two steps are getting you guys to find the slope and the y-intercept. However, the exponential equation is a little different, but we still need that constant multiplier and that y-intercept. So we keep repeating the steps with you guys so we get to the point where you can write those equations, and it'll be a piece of cake by then, hopefully. Okay, so you didn't see a decreasing linear function today during your Desmos activity, but you have seen that before. So we're going to start talking about your decreasing linear functions. And a decreasing linear function, when you graph it, shows us a line that goes down. So a little bit of review for you guys. Who can tell me if the slope is going to be positive or if the slope is going to be negative on a line that's going down? Should it be a positive? Say that again?
Going to be negative because you put your name on it that it's going down, so it's negative.
Yeah, there you go. Perfect. The slope should be negative. Okay. So when we're looking at a table that is going to show us a decreasing line, okay, we're looking for a slope that is negative. So look at your tables here. Oops, that went too far ahead. Your y values. You want to find the pattern in your y values. 10, 8, 6, and 4. If you guys caught my computer going a little crazy there, you probably saw the pattern. But think about a rule or an operation that we're doing to 10 to give us the 8, and then from the 8 to give us a 6, and from the 6 to give us a 4.
Divide by 2.
So 10 divided by 2?
Oh, no. It's subtracting 2.
Yes, good job. Yeah, perfect. So we are subtracting by 2 each time. So 10 minus 2 is 8, 8 minus 2 is 6, and 6 minus 4 is 2. So a little bit of review from yesterday. When we had those tables that had a positive or an adding pattern, we saw a line that goes up. Today, you're seeing that when we have a negative pattern, we have a decreasing linear line that's going down. So a linear function that is decreasing has a subtraction pattern. Okay, so this is your first step. Always start off by looking at those y values and asking yourself, what pattern am I seeing here? If it's adding or subtracting, we're talking about something that is linear. Okay, we're gonna go over to your Classkick notes and drag those options up. Our objective for today is to be able to tell the difference between the decreasing linear and decreasing exponential functions and find their features. So we want to identify those. When we're looking at our decreasing linear, our points are going to show us a subtraction, a line that goes down. And it's going to show us a minus pattern, a subtraction pattern on the y values. That's what you should have right now. Always start off by finding that pattern. Right now that we're seeing a negative pattern, it's a subtraction pattern, gives us a line that goes down. Okay, give me a thumbs up if you're ready to move on. Give me a clap if you need more time. Okay. So in the decreasing linear, we have a subtraction pattern and we're moving on to the exponential side. This is what you guys saw in that green pattern, the green grids. Okay, you're gonna want to remember that when we put those green points on our graph, we saw a curve, but this curve was going down. We cannot call a curve linear because you got to remember that a linear function is a straight line. Even though we're not curving like yesterday going up, it's curving down, which means it has to be exponential. Okay, so first step, when you have a table, always start by finding a pattern in your y's. So take a look at these y's, 32, 16, 8, and 4. What pattern or rule can we find that gets us from 32 to get to 16, from 16 to 8, and from 8 to 4?
Division?
Yes, very good. Division. So what are we dividing by each time here?
2.
Yes. And boys and girls, it's my bad. I'm not sure if anybody picked up on it, but they're almost the same numbers. We're just starting at 32 here. They're almost the same numbers as your Desmos activity. But you'll see towards the end an example of different numbers, so don't worry. Okay, 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. Okay, so there's one important part here though. When we see a division pattern, I'm using quotes to talk about a division pattern because in our exponential functions, our exponential function, when we're writing that equation, we don't have division in there. It's only multiplication. So remember I said it's only going to be a multiplication pattern, okay? There's a way to change division into multiplication. I don't know if any of your teachers taught you the keep, change, flip, KCF, almost sounded like KFC. When we divided by fractions, you had to keep the first number, change the operation, and flip the fraction. We're not going to really worry about KCF. What I want you to keep in mind is the CF, the change and flip. Whenever you see division, that's exactly what you want to do. You want to change that division to multiplication and flip the 2 over into a fraction. Okay, so the reason being is that when you're dividing by 2, it's like splitting everything. You're splitting in half. To show that we're splitting something, you could use division, but we can also multiply by those fractions. So if we ever divide by 3, okay, that changes into multiplication and flipping the 3 to 1/3. If we're dividing by 4, you're going to change to multiplication and flip the 4. Do you guys see that?
Ms. Gomez,
Yes.
weren't we doing KCF when we were doing the homework on Tuesday?
Tuesday. With the slopes?
Yeah, like with the graphs. Because if the x was negative, we had to change everything to positive or opposite.
If the x was negative.
Yeah, because we were dividing by a -1, but that's different I mean, it's similar. You're on the right track, but
Mhm.
we don't call it the same thing when
Yeah.
we're multiplying versus adding.
Yeah. That's when you are turning something positive, and if you do something to one thing, you have to change everything to keep it balanced. So again, dividing is actually a multiplication pattern, and that is a multiplication pattern by a fraction. So a decreasing exponential, you should be looking at a fraction. Okay, that's how we get a decreasing pattern, or as you guys learned today, decay. So decay is another word to refer to decreasing. Okay, we're gonna go over to your class kick notes. We're talking about the decreasing exponential this time. Which gives us a curve that's going down. I like to think of it as a little slide, like a little person going up here. If they get on the slide, they come down. That's how you know you're looking at a decreasing exponential. Okay, we need to find a pattern by looking at our y's. And we see that we're dividing by 2. So a division pattern is an exponential, but we want to refer to it to multiplication. So we have to change division to multiplication and flip that fraction. Sorry, that number to a fraction. So that's what you should have up right now. And keep in mind, we're getting you guys ready to write these equations. And these equations need those 2 steps. The pattern, which is our rate of change or multiplier, depending on what you have. And we're going to move on to the second step right now to find that y-intercept. We need that, just like your y equals mx plus b needs y-intercept and slope. We're going to need our pattern for exponential and our y-intercept as well. Okay, give me a thumbs up if you're ready to move on. Give me a clap if you need more time. Okay, I'll give you guys more time. Okay. Okay, so that first step gets us the rate of change or the slope, or sorry, the rate of change or the constant multiplier. If you found a subtraction pattern, then we call that the slope or rate of change. Same thing, just different words. So on the linear side, we saw that our pattern was to subtract by 2. So that means our slope is going to be what?
0 and 12.
Our slope. You're going one step ahead of us. The pattern.
-2.
Yes, perfect. So our slope is our pattern, -2. Very, very important that you keep that negative in front, okay? Because we're talking about a line that's going down. Remember, if we have a line that's going down, we should have a negative slope. So it's very important that you keep that -2 there, the negative. So remember, when you find the pattern that is adding or subtracting, you found the rate of change. It's just that number we found, -2. On the other side, our constant multiplier, what you are multiplying by over and over again, okay? And remember, multiplier has the word multiply. What is it that we are constantly multiplying by over and over again on the exponential side?
1/2.
Yeah, perfect. It's divide by 2, but remember we changed that to multiplication and flip the number. We get a constant multiplier of 1/2. It's a fraction. If we're going down on a curve, that has to be a fraction for your rate, for your multiplier. Okay, let's go over to your Classkick notes. Just 2 pieces to drag over. On the linear side, we saw a subtraction pattern of 2, so that is our slope. On the exponential side, we saw we're multiplying by 1/2 over and over again. That is our constant multiplier, the 1/2. So just 2 pieces to drag over this time. Give me a thumbs up if you drag those over. Give me a clap if you need more time. All right, here we go. Okay, so after the first step of finding our pattern, which gives us the rate of change or the constant multiplier, we need to find our y-intercept. Okay, so far, we have that our slope was -2 on the linear side. So if you remember, we're trying to get you guys to write this, y equals mx plus b. We're not doing that today, but I'm showing you what's to come in the future. This was our slope. So far, we found that was -2, so we should have -2x. We need our y-intercept. That is our step number 2. Finding the initial value or the y-intercept. Okay, our y-intercept, we can find that when x is 0. So this piece right here matches to that y there. To do that, we have to use our pattern and go backwards. It's like instead of going in the direction from 10 to 8 to 6, you have to think of, well, what came before 10? Okay, and we can just use our pattern to go backwards. That will get us to 0 here. But if we're going backwards from 10, what should we do to the 10 to find that number that came before it?
Add 2.
Add 2, yeah, good, very good. Think about it. If our pattern was to subtract 2 each time, if we want to think about, well, what came before, you have to go backwards. So you're going to want to add 2. So take that 10, add 2. What do we get? What's 10 plus 2?
12.
12, good. So we get our y-intercept that way. Our y-intercept is at 0, 12, or when we're writing the equation, we could just say it's at 12. With these 2 pieces of information, you're ready to write your equation. Our slope was -2, and our y-intercept is a +12. These 2 things got you to write that linear equation. And next week, you're going to see how we write the exponential equation with the multiplier and with the y-intercept. Okay, let's go over to your Classkick notes. Let's fill in the second step for our y-intercept on the linear side. We said we can find it by going backwards. When we went backwards, we got 0, 12. And I'm actually going to have you guys draw this in because I saw some of you struggling with the going backwards here. 10, if I'm moving back this way, I had to do the opposite of -2, which was to add 2. That y-intercept is important, boys and girls. So now that gave us our y-intercept, and we can go ahead and drag this piece over. 0, 12 is our y-intercept, which means our y-intercept is just 12. So that is a linear function that's going down, a decreasing linear. Okay, give me a thumbs up if you're good to move on. Give me a clap if you need more time. Okay. We're going to try to find the y-intercept now for your exponential function. Remember, that is when our x equals 0. So we can go backwards to get this piece here. And here's the thing, boys and girls. A lot of teachers will not give their students a table that has this blank here. Okay, a lot of teachers will have you guys just start at 1, 2, 3, and go up. And when it comes time to writing the equation, they're like, okay, well, you have to find the y-intercept, but there's no piece there to help you out. So we're helping you guys out by including that blank space up there to remind you, oh, I got to go back. Okay, it's a reminder. So if we're going back, we need x here to be 0. But this time I'm going to have you guys think, if we're at 32 and I'm going backwards, the opposite of the pattern here, what do we have to do to find the missing number on top?
Multiply?
Yes, good job. We're going to be multiplying, and multiplying by what?
1/2.
Oh, that's our pattern right here.
Oh no. So since it's divided by 2, you're gonna have to do the opposite and divide by 2 and multiply by 2.
Yeah, you got it. Good. So this time we're multiplying by 2 to take it one step back to go backwards. Have that in mind. If we're going backwards, that's the opposite. Okay, so what's 32 times 2?
64.
Good. So that is 64. So our y-intercept is at 0, 64. Or you could just say y-intercept at 64. So a couple of things for those of you that were really interested in writing that equation, the constant multiplier we said was 1/2, and our y-intercept was 64. We need these two pieces of information to write an equation. And we're going to keep practicing this on Monday and Tuesday, and by Thursday we should be writing those equations. Okay, let's go over to your Classkick notes. To find our y-intercept as our second step, We can go backwards. That got us 0.64. Okay, if we go backwards here, we do the opposite, which was times 2. Keep in mind, we need the opposite to go backwards. That tells us our y-intercept is at 0.64 or just 64. Okay, so this finishes up the part with our notes. So I'm going to let you guys take a screenshot of that top half there. If you were not able to follow along with us today because of internet connections, take a screenshot and you can complete it afterwards. Remember, today's Friday, so you should be getting close to finishing your notebook and turning that in.
So I forgot to click on a little switch in Classcake, so it wasn't self-grading the your turns. If you guys go back, same thing for those of you guys who have already done the slope activity. If you guys go back, it'll now self-correct. So now you'll be able to see that it was like if you're doing it correct or not. So sorry about that, guys. But yeah, it should self-correct now.
Okay, I'm gonna move it over to the bottom half. For those of you taking a screenshot, go ahead and take a screenshot so you can complete the second step. And before we let you guys go to lunch, we're gonna go over a practice problem on the Your Turn page. So the Your Turn, remember, is where you get to try how to find if these are linear or exponential, the rate of change or multiplier, and the y-intercepts. So we're gonna try one problem together to give you guys a little more practice. So we'll go over to page 7. I gave you guys a hint up here that there are 2 exponential tables and only 1 linear table. So from these 3, one of them is linear and the other 2 are exponential. We are going to be working on the last table here together. And we're going to be walking through those 2. I'm going to be walking you guys through those 2 steps, but you guys are going to be helping me by giving me the answers. So give me a thumbs up if you're on page 7. Okay, so on page 7, you want to find out if it is linear or exponential. To find that out, you need to start by first looking for the pattern. So I'm going to give you guys a couple of seconds to see if you can find your pattern that gets us from the number 16 to the number 4 to the number 1 and to the number 1/4. You can either type it in to me or to Doc Brown or to us all, or unmute yourself and let us know.
What?
Say that again.
This one, the first pattern, 16, 4, 1, 1, 4. It's gonna be
Exponential?
Yeah.
Yeah, it is exponential. Now tell me, why is it exponential? What is the pattern?
You're dividing.
Yeah. We are dividing. Good job. And each time 16 divided by something gets us 4. 4 divided by that something is going to give us 1. What is that number? Oh, thank you, Jessica. Divide by 4. So we're dividing by 4 each time. That is an exponential function. That's going to give you the curve that goes down, the little slide. Okay, if we have an exponential function, is our pattern going to be a rate of change or a multiplier? So you can tell me in the chat if you want, give me an R for a rate of change, or give me an M if we are going to call it a multiplier.
Rate of change.
Rate of change. I got one rate of change, one multiplier. Anybody else to help break the tie? A multiplier? Yes. So if we are talking about an exponential function, we have a multiplier. Remember, we're constantly multiplying over and over again. So if we're multiplying over and over again, we need to change this divide by 4. What does the divide by 4 change into when we're talking about multiplying? Let me know in the chat. Or you can unmute yourself. Remember that KFC. There you go, multiply. Change and flip. So multiply by, it wouldn't be multiplied by 4.
Divide by 4?
Yeah, if we're dividing by 4, remember we said,
Multiply by 1/4.
there you go. We can change division to multiplication and turn the 4 into a fraction. Flip that over, change and flip. So that's times 1/4. Divide by 4 means to multiply by 1/4. Divide by 4 means to multiply by 1/4. So that is your constant multiplier, that we are multiplying by 1/4 each time. So you should have a fraction here, 1/4. And notice how that gives you a green check. It's because it's showing you it's correct. So to divide by 4 each time is actually to multiply by 1/4 each time. We're multiplying by a fraction when there's division. Okay, we're at the second step. Your last step is to find the initial value, to go backwards and find this spot here. So what can we do to move back? To find the y-intercept? You can unmute yourself or you can message me on the chat. What can we do to go in the opposite direction?
Multiply by 1/4.
Oh, close. So if we're going back here, we are going to have to multiply, but we are multiplying, yes, Jessica, by 4. Okay, this here is our multiplier. If you're unsure why, this was our multiplier. That gave us our multiplier. Our pattern was the divide by 4 each time. So if we're going backwards with that pattern, we multiply by 4. So we need to figure out what 16 times 4 is. Who can let me know what 16 times 4 is? You can do it on the chat or unmute yourself.
$64.
Yes, good job. 64. And remember, we need to put in that 0. 64 here. That is our y-intercept, our initial value at the end here. It's putting it as a on top of each other here, but they should be side by side. There isn't enough space there. So that should say 64. So again, there's always 2 steps. Find your pattern. Is this adding or subtracting? That would mean it's linear. Is it multiplying or dividing? That's exponential. Your pattern gives you the rate of change or the multiplier. And then go backwards, do the opposite to find the initial value. But we'll have practice next week. It seems to me like the one where most of the students struggle is the y-intercept, but we're gonna have practice with that, and you're gonna see it visually with graphs next week. Okay, I'll leave that up here if you guys want to take a screenshot of that to help you out with the other two problems here. There's gonna be only one linear and one exponential. So you guys can finish those for homework. Let us know you're done by raising your hand and say, please check, so we know that all of your notebook there is done.
And then your exit ticket has already been like released to you guys like 10 minutes ago. Once you guys are done with doing your exit ticket, you guys are free to go. Remember, you still need to do the 2 your turn questions on this one and the one that you did yesterday before you guys can turn in your notebook. But other than that, guys, you guys are free to go. Have a very good weekend. We're going to continue this. Remember, this is just the intro to this, and we're going to continue working on this all of next week. But you guys have been doing an amazing job. So great.
Have a good weekend,
Have a good weekend, guys.
or we'll see you during tutoring.
Bye, Ms. Gomez. Bye, Doc. Have a good weekend.
Thank
You
you.
too.
Bye, Doc.
Bye.
Bye, Ms. Gomez.
Bye.
Bye.
You can stop recording, Doc.